Okay, so where did this come from? How do we start out when it comes to computer forensics? Well, we just have to back up and we have to start talking about forensics. Well, fingerprints. That's where this all came from. If you go back before 1888, there was actually a scientific measure of the body itself. I don't remember the name of it, but what they found out is that they said the idea theoretically is that all humans were different, and if we measure all their body attributes and we take all the measurements of their head and body and arms and lengths and fingers and toes, that is unique to a human, and they found out that that's not true. But when they dug deeper, they figured out, hey, fingerprints, they are unique to every human that we can find. And then later on in 1915, they started talking about blood grouping. A, B, positive, negative, those kinds of things. And being able to say, hey, when we see a blood splatter here, is this the victim of the crime? Is this their blood? Or could this be the attacker, the person that actually committed the crime? Could it be their blood that's actually there? Could we pick up their jacket and go, hey, look, there's a little bit of blood on your jacket. Why don't we test that and see if that matches with the blood of this crime over here? Then in 84, computer analysis kicks in. The FBI starts talking about this, and they created what was called CART, Computer Analysis and Response Team. And again, in the early 80s, what they did is they drew a line around $1 million. It's not exact science, but that's usually the hint toward it. And in 2000, we kicked in with the Regional Computer Forensics Laboratory. It was established. And those are regionally in the U.S., and they're actually happening all over the world according to the directives of the IOCE. Okay, so formal definition. Here it is. Application of physical sciences to law in the search for the truth in civil, criminal, and social behavior matters to the end that injustice shall not be done to any member of society. Then what we want to do is we want to determine that evidence value toward this crime scene. And we want to find out what the related evidence is. It's not just this one thing. It's not just that one computer. It could be the peripheral devices on it that have recorded things. It could be the camera that was hooked up to it at one point. It could be the phone that's hooked up and synced to it at one point. We have to figure out what the value of those things is. That will become very important when we go to get a search warrant. Scientists properly analyze the physical evidence and provide expert testimony in court. You need to be a scientist. Now think about all the things. If you go back to the time that you were in chemistry in high school, what did you do before you did an experiment? One of the classic things is clean all your equipment. Why did we clean all of our test tubes and Bunsen burners and all the different tools that we were going to use before we actually performed the experiment? Because we realized that if we didn't, we would get bad results. We would taint the experiment. It wouldn't work out correctly because there would have been an element in there that shouldn't have been inside of that Pyrex tube. See, that's the thing. As scientists, what we do is we say, we'll set from zero and clean things up. We'll do our experiment, and then, most importantly in that experiment, and this is about forensic scientists from a computer standpoint, is that anybody that does this experiment or does this analysis will achieve the same result. And there's the key. You need to be irrefutable in a court of law. And we'll talk about the courts in a little bit. Okay, so now let's dig into the benefits, the objectives, the methodologies, evidence, and how we do this in an organization. So what we want to do is we want to ensure the overall integrity and continuity, continued existence of the organization's computer systems. You want to make sure that if malware gets on the machines, that we can actually get it off. We can research it enough to say, hey, we know exactly what we're doing here, and here's how we can stop this in the future. Unfortunately, today in a lot of corporate organizations, the most expedient thing to do is to re-image the machine. Now we're starting over at that point. What about the evidence that was there? It's gone. I mean, that's really the problem. So organizations say, well, it's easier to get the person up and running if we just wipe out their machine. Well, wait a minute. Why don't we give them a different machine, take this machine, and then capture that information? Why don't we trade out machines? And that's what my friend Bill Lardisky taught me very early on. He said, hey, look, we don't want to go ahead and slow down business because business has got to get done. So let's take that computer away, put this computer down. If we've got the correct roaming profiles and all the other activities on there, they can log into this machine. We can take this back and we can figure out what's wrong with it, or basically we can crush the machine if we can't figure it out. But we'll note all that information back here while business keeps going because that is key to any objective. We want to capture that important information if the computer system is compromised so that we can say, hey, you know what? We could fix this because, well, we could patch and we could make that work out for us. And then really, if we get past that point of getting business up and running and then stopping these attacks in the future, maybe we want to say, I want to go prosecute this person. This person snuck onto our web server, did these activities, and it cost us millions of dollars, and they siphoned millions of dollars off of our organization, and we can't afford it, but we know where they are. Well, how do you know what they are? Well, you do a forensics investigation. Then you're going to track down those cyber criminals, maybe even some terrorists. And then that causes a problem. Even though it's a benefit to the organization, this tracking, this recovery in the case, this tracking cost time. Okay, so what are our objectives in forensics? We want to recover, analyze, and preserve the computer and related materials sustainable to our evidence for court. We're going to bring it there. We're going to take it all together and we're going to say, hey, we've seen this thing, we know about this thing, and here, court of law, take this on. Now, to present that, we have to do a lot of things. We'll get into chain of custody in a bit. We also want to identify this evidence in a very short period of time. So that means that we need to build up tools and activities that can condense this down. When I talked to local law enforcement about phone forensics, because that's where they capture a lot of information at this point, how long do they have to capture this information off of this phone? Well, they have to return this evidence because this evidence is the property of somebody else. So they have to go ahead and plug that phone in, suck off that information, and then hand that back to that particular person unless they actually pull that information off, see that there's evidence in here, and then seize this piece of information. Seize this phone, if you will. So we've got to do that in a very efficient manner so that we can say, hey, look, we have the right to hold this suspect, we have the right to hold their property, we have the right to review these things, but if we can't find anything in a short period of time, we've got to release them. Now, the methodology comes down to this process here. Preservation. The things that we collect, that we keep correct. Identification. The things that we collect, when we search through them, we find those elements in the set that help us to define the crime. Extraction. We pull those particular elements off the set and we get them ready for display to somebody else, and we put the interpretation or the analysis around it. In that interpretation, what we're saying is these key pieces of evidence match up scientifically with this particular activity over here. If it was a cell phone, we have to replicate that on a clean phone in a lot of cases. Then we document all this information, and we're ready to present it in a court of law. Okay, so we need this broad test for evidence. So, what's the broad test? After the evidence is collected, investigators perform a general test on the evidence to determine its authenticity and reliability. Authenticity means that it came from that person and we can attribute those actions to them. And we can attribute that repetitively. We can reliably say that is in fact something that that person does, and it's not a guess. It points to a pattern of activity that we can trace to an individual. Okay, so now what's evidence? Well, to be honest with you, it can be anything. Sometimes it's a few bytes. Now, I will tell you, by the way, it's not a few bytes once. There's no smoking gun. There's no bullet hole in the person. It's usually a pattern of activity over a long period of time. So it's as small as a few bytes, but those few bytes are all over the place. If we went to court with one set of bytes of information and we said, this proves that he is guilty, well, the opposing counsel could go ahead and say, well, let's see when this is possible that this wouldn't be the truth of it, if it was just one piece of evidence. But if we go, we've got all of this, and this, and we've got all these different patterns of activity attributed to this one person, You know what? They could probably knock off one or two of those things, but not all of those things. It could be the complete files. It's probably fragments of files. And people will go in and delete a particular file, and then that particular space on that hard drive is overwritten. At least the first couple of sectors are overwritten, and we may have some of the final sectors that have not been overwritten, and we can pick up a piece of that email or a piece of that text message and actually present it. But we'd have to have lots and lots of pieces of this. Sometimes we're looking for a few words or paragraphs, and sometimes that's all we get. Now, what's really amazing on the Windows side of things is that the registry entries can actually prove a lot of activity. Because we say we delete it here, but it's sitting somewhere like in a shadow copy or shadow volume copy. That's system state data stuff for those of you who have been around a while in Windows. It's that collected information. It could even be some files at that point, some old versions of those files. So let's talk about the aspects of organizational security. Remember, this is not just about forensics for our organization. In IT security, what we're doing is we're saying, hey, there's all this activity, and we need to, in a forensic way, collect that information so that we can make sound decisions and base those decisions based upon scientific evidence collection, not just a guess by somebody. Physical security. We want to make sure that, hey, you know what, we won't allow you to take that phone with you or that computer with you. It has to stay in this particular location, and that allows us to maintain that crime scene for that computer that's sitting there. Financial and legal security. Obviously, we want to make sure that the company is solvent and that we can't be prosecuted. Sometimes when we talk about legal security, we're talking about e-discovery. And a policy in your organization may destroy evidence inappropriately because it says, hey, we will shred after this particular date, and that's inappropriate according to the laws that you have to pay attention to. So that's the aspects of organizational security.